Hello all. Today we're going to discuss about the data types. In the previous class we have discussed about the data types and I have given some brief, not brief, some small introduction to the types. In this class we're going to discuss about the data types into the deeper. Basically the data types are divided into two types. Those are nets and variables. Nets and variables are the two types of data types. How these data types are being classified, which is given in the above, sorry, previous video. So we can see the primary intent of data type in which Verilog is to represent data storage element. One thing is we need a data type which uh, acts as a storage element like flip-flop, and we need another data type which acts as a transmission element like wire. So based on this intent, we have classified data types into two types. Those are net and variable. Net and variables are the two main groups of data types. These are the two main groups of data types which represent hardware structures. The flip-flop and the wires are the hardware structures, right? Yeah. And differ in the way they are assigned and retained values. Okay. Let us discuss about nets in this video. Nets are used to connect between hardware entities like logic gates. Let me clear what is actually the net is. Okay, so nets are nothing but a wires which are used to connect between logical gates or two or more devices. Simply access a wires. Nets contain some other types of wires as net contains some other types also in it, so it do not store any value on its own. The wire can't able to store any value, right? It just simply transmit information from one place to another, like the wire. Same, the net data type acts. It means like the wire, which is only responsible to transfer data from one place to another. Similar the net data types acts as transmitting data from one place to another. They can't able to store the value. There are different types of nets. As I have discussed previously, there are different types of nets, each with different characteristics. But the most popular and widely used net in digital design is wire. There are different types of nets like uh, wire, war, band, tri, trior, triand, etc. Among these, we mostly use the wire. Wire is nothing but a simply a physical wire. It's like a physical wire. Whereas war, band, trior, triand, these are not the simple wires. These data types performs operations on the data and then transmit, whereas wire simply transmits the data given by one side to the another side. Okay, that's the difference between wire and war, band, trior, triand. So that's why we mostly use wire. Why? Because it simply just transmit the information from one place to another like a physical wire. Whereas war, van, trior, triand, all these performs a particular task, whether it may be a or and operation on the signals that are assigned to these data types. Okay, so let us discuss about wire in detail. A wire is a Verilog data type used to connect elements and to connect nets that are driven by a single gate or continuous assignments. Okay, so it's just a simple physical wire. It's like just a simple physical wire. It just use it to connect two individual blocks or two individual gates or any connection between the components. Will we will use wire to connect them. Okay, the wire is similar to the electrical wire. As I have discussed, the wire is similar to electrical wire that is used to connect two components on breadboard. Like similarly, while we are doing experiments, we usually place components on the breadboard and we use the physical wires, right? Like that only this particular white data type acts. When there is a requirement of multiple nets, they can be punched together to form a single wire. Okay, let us see the syntax. It means what this point means. It's telling about the vector representation. The previous class I have discussed some small details about the vector, right? So when there is a requirement of one more than one wire, you can able to uh, prove you can able to use the vector representation to for representing multiple number of wires. So this is the syntax for the wire and the name of the wire. Okay, this is the scalar or a single bit wire. This particular syntax is for the scalar or single bit wire, whereas syntax for the vector representation of wire data type is wire followed by the range followed by the name. Remember that the range should be always right to the data type and left to the name of that particular data type. Here in this case, the range is right to the wire, whereas the range is left to the name of that wire B. It is a 4-bit wire and this is a vector. It is a 4-bit wire and it is a vector in which 4 bits include P of 3 and P of 2, sorry, yeah, P of 1 and P of 0. Yeah. It is illegal to redeclare a name already declared by a net parameter or variable as shown in the code below. It is illegal to redeclare a name already declared by a net, or maybe it may be a parameter or maybe a variable as shown in the code below. Means the code, if you are gonna see in the below, we have declared we have taken the module design whose name is design, and we have declared some of the variables in the module like wire abc, wire a, wire b, wire c, and again we have declared the wire abc. So if you're gonna see over here, we have declared wire abc two times. So this is not uh, legal in Verilog. It is illegal to declare same variable name two times. Okay, it is called identifier abc previously declared. Whenever you gonna assign the same variable two times to a particular data type or any other data type, then you will get the error as identifier abc previously declared. So this is the particular error, and I'm gonna show you what's the difference between scalar and vector, the paint. We're gonna see over here this particular thing. The first thing here, wire A I have written, right. This is a scalar representation. Scalar of wire, which is a single bit wire or a single wire. Okay, yeah, with whose name is A. Whereas if you're gonna see over here, there are four different wires, namely W of G3, W of 2, W of 1, W of 0. All these combined we can use, or else we can use them separately as a single bit. All these wires representation combinedly represent single value, okay, or else you can separately use the W of 0, and you can also use W of 1 separately, W of 2 separately, W of 3 separately. Okay, to call individual wires we will use W of that particular position value of the wire. Okay, to call whole complete wire at a time we will use W. Simply we use W. And if you're gonna see over here, we can represent or we can declare four wires like this. Okay, we can use this particular statement to declare four different wires. I hope you got the difference between the scalar representation and vector representation. Now you have a doubt where we wanna use this particular uh, wires. So for suppose if you're gonna have like this, sorry I am picking drawing. So if you're gonna take the AND gate, and if you're gonna take another AND gate, you're gonna take AND or logic. For example, I have taken two AND gates, and two AND gates outputs are being connected OR gate, OR gate, which represents the AND or logic. So now if you're gonna take this particular circuit, so what are the inputs, what are the outputs? Just mark it. So let us mark it. So this is the red color line which represents the block, right? So gonna see. So this is the inner circuit. So if you're gonna see the what are the outputs uh, and inputs, we can see there are two inputs to the AND gate. Let us name them as A and B, and we have again two inputs for the another AND gate. Let us name them C and D. And if you're gonna see over here, we have one output, we can present it as Y. So gonna see in the internal circuit. I'm not talking about the external circuit. The external circuit wires or the things that we gonna see, we should represent them as inputs and output wires. These also are the wires. These A B C D A comma B comma C comma D comma Y are also wires, but they are external wires which are visible to the user or the customer. So we should declare them as inputs and outputs. In this case, A to A, B, C, D will be considered as inputs. Even though it is an input, it is the type of wire. Okay, we should declare input wire. Okay, for y we should declare output wire. Okay, even though you are using wire or not, by default input and outputs are wires only. Remember this point. Okay, all these points will be discussed in the future also for you guys to make get prepared for the future classes. I am gonna tell these particular points in classes. Okay, so what about these particular internal wires? So internal wires, these are not the puts to the circuit nor the outputs to the circuit. These are the intermediate results, right? So what we have to do is we have to take wires. So let me take this as W, wire W, and let me take this wire as X. Okay, so like this way to represent internal wires of the circuit we use wire, even though the for these inputs and outputs are also treated as wires only, but for the inputs and outputs which are going to visible to us, we will also declare them as wires. Along with that, we have to mention what are the inputs, what are the outputs. In this case, A, comma B, comma C, comma D are the inputs, Y is the output, whereas W, comma Z are also a wires, but they are not treated as inputs and outputs because they are the terminal wires. Okay, in this case, we have to use wires. So, if you want to see over here, the data from AND gate 1 will be directly transmitted to the OR gate input. Okay, and also similarly the data from AND gate 2 will directly transmit to the OR gate second input. So in this process there is no chance of storing the value. So wire can't able to store any value. So we have to remember these particular points. Okay, I hope what I hope understood. Yes. Okay, let us say an example how I'll give you some overview why what is what. I'm just commenting this particular codes for your better understanding purpose. So that yeah, if you're gonna see the code here, I have written a code. I have declared two variables, namely A and B. A is a single bit vector or single bit wire, a single bit wire, okay? Whereas B is a 4-bit wire which is in the vector representation. I'm gonna print out the values of A using the binary format specifier. So let me print these values. Let us see whether these values are being printed or not. Yeah, me gonna run this program. Yeah, we got two errors as expected. Why we got two errors? Let's see where are they. Yeah, 407. A is not valid L value in wire. A is declared here as wire. B is not valid L value in wire. It means in the initial begin block, you shouldn't use LHS value as wire. Remember this point. This is also very important in the coming videos. We'll get it. Okay. The initial begin block shouldn't use the LHS value as wire. So what I'm gonna do is you can able to use wires with mostly assign statement. You can use wires with assign statement. Okay. So can able to use wire with assign statement. So I have written an expression. Let me rerun this program again. Operation failed. $display requires system Verilog. Why this error we get it means we have to use system task in either initial begin statements only. So here we have only one single statement. For that reason we shouldn't use begin and end. It's our choice whether to use or not using it. So if you're gonna see over here, you get A equal to 1, B is equal to 1 0 1 0. Okay, A equal to 1, B equal to 1 0 1 0. So I forgot to tell you the points here. By default you have to remember the by default values. By default wire is a single bit, uh, while is a single bit, while carries by default wire can carry single bit. Okay, yeah, let me this. sorry. By default, wire can carry single bit. Can carry single. Okay. Now by default, wire can able to carry single bit. Okay. So what is the default value of wire when we haven't if we if in the case we haven't assigned any value to the wire, what is the default value? So let me we have to know these particular things. These are the most important things in the interview point of view. So let us comment these particular statements. I'm not gonna assign any value to both the A and B right now. So I'm gonna print this statement by saving. Let's see what value we are going to get it. So if you're gonna see, we got the value Z, high impedance. So in the previous class, we have discussed about the high impedance. High impedance means unconnected wire, right? So for that reason, we got the value as Z. So it means from this statement, we can, from this exercise or the statement, whatever you think, we can able to state that by default, wire can carry single bit. By default, wire value is Z bracket high impedance. Okay. So, and the third important point that you have to check is, so whether wire is a signed or unsigned, you have to check it. So for that purpose, what we can do is, so let us take this thing. So let us comment this particular single bit array, single bit wire. So and let us assign this value the decimal format, which is 10. Let us assign the minus 10. Okay, let us assign the minus 10. If wire is a by default, if wire is a by default, wire is a by default unsigned, then we should get the value 2 power 4 16 minus 10 4. If y is signed, we get 4. If signed, we get minus 10 as usually, right? So let us see what happens. In the previous class we have seen all these things. Sorry, I got 6. Why how is was 2 power 4 16 minus, yeah, it's 6. 2 power 4 16 minus 10, which will be 6, right? Yeah, we got 6. It means by default wire is a unsigned data type. So that particular thing also you have to write it by default. All these things you have to check it for any data type. By default wire is unsigned. So to make it signed, you should simply mention the modifier over here, keep here. So I've said it, but also we will get an error. Let's see. So it's the error which we got in the previous class. I have told you, right? After the data type we should mention the modifier. Before the data type, if we gonna mention the modifier, it will shows the error. So remove this sign and place after the data, and you guys run, then you can able to observe the output as minus 10, right? There is this uh, oh, it's getting 6. Pause. Let me check this. Yeah, Why you got 6 here is actually in Verilog when we are gonna use 2 power 4, we can actually represent how many number of values? 16 values, right? We can represent when we're gonna use 4 bits, we can represent 16 values, and those 16 values are being ranging from 0 to 7, the positive, and -1 to -8, the negative, right? So here I have used -10 to represent -10 and have given only 4 number of bits, right? So it's not in the range of 0 to 7 or -1 to -8. It means it getting overflowed, right? For that particular region, we are getting the 2's complement result of -10, 6. Okay, let us put the here some 6. Okay, sorry, not 6. Let us put 8. Okay, let us see the output. We will get, I think we will get the, let me check this. So if we are gonna see over here, we got the output -8. Okay, if you're gonna remove this particular sign, then you will get what you will get the resultant as 16 minus 8 will be 8 plus 8. Let us see. So if you're gonna see, I have removed the signed modifier, then we got the resultant as b equal to 8. The previous class I put the signed modifier, we got the resultant as -8. Okay, this is in this class we have learned some new point, that is whenever we gonna use assign the negative number. For example, I'm gonna assign you 11. Okay, so and let me check by giving signed and unsigned as well. So if you're gonna see, we should get how much? Should get 5, right? Which is a 2's complement resultant of -11. So if you're gonna remove this particular sign, again also you will get, I think minus, I think 5 only. Let's check. Let me check. Yeah, you got the 5. Why? Because even though you are using, even though when you are going to use, I haven't mentioned sign, right? Sign and reprint. So now we should get actually -11, but we are getting 5. This is why, because even though we are using the signed modifier after the data type while we are storing -11 in 4 bits, right? But it is getting overflowed, right? The value is out of range. The using 4 bits we can only represent the values from 0 to 7 and -1 to -8. When in the case of signed, the case of unsigned, we can represent 0 to 15, right? So because of this reason, can't able to represent -11 in the 4 bits, so it is going to represent the -11 in its 2's complement form only when we gonna use unsigned as well. Okay, so this is the thing. These are the key takeaways this lecture. Points to be remembered: by default y can carry simply, but y y value is shared, which is high impedance. By default y is unsigned. When you assign the out of range negative number to any data type, then the variable of that data type can store the value on spot. Store the value to overflow. So if you assign this signed modifier after the data type, or if the data type is signed by default, we won't get the negative number while printing. we get its true complement from our. This is all the key points that are need to be observed while you are guys are seeing. So this is all about the lecture. Let's meet next. Sure. Thank you. Like, share, subscribe. I don't uh, want all this. I just need the suggestion. Suggestion is the most important thing it's required for change over myself. So I definitely need your guys support like, share, and subscribe along with more, along with not along more than that. I need to respond how you guys are feeling about the lectures. Is there mistakes or is there any that I need to change myself, communicate like this feedback I need. So I request if you guys like this video, please like, share, subscribe. You guys didn't like this video or do you want me to change my style or want to keep suggestion? I request you guys give me the suggestions so I will definitely follow through and change myself. So this is the only request that I am asking you. So that's all. Thank you guys for this. Thank you.